Good morning, students. I am M. Venkataya, Assistant Professor in the Department of Mechanical Engineering at Vignas Lara Institute of Technology and Science. So now I am going to teach the subject is thermal and hydro prime movers. So this is the fourth unit, impact of jets. So see here, this is the syllabus of topics of fourth unit, that is impulse momentum equation. This is a impulse momentum equation already completed. So in this impulse momentum equation, that is already completed, and impact of jets on stationary and moving vanes. So impact of jets on stationary and moving vanes, flat and curved, is also completed, and problems also in the previous class completed. Okay, so now in this class I have discussed the pumps. So different types of pumps, that is the centrifugal pumps and the reciprocating pumps, the working principle of centrifugal pumps, okay, and multi-stage pumps, performance and characteristics curves. Okay, this is the topics of second part of the fourth unit, working principles of centrifugal pump and multi-stage pumps, and performance and characteristics curves. Okay, so this is the in this today's class I have discussed the different types of pumps, that is centrifugal pumps, main components, and the working principle, multi-stage pumps, performance and characteristic curves. Okay, so characteristics curves we are discussing from this class. Okay, so see the first of all, that's the pump terminology. We have to understand we should understand the terminology of pumps. So here the pumping, the addition of energy to a fluid. So the addition of energy. So pumping system we see in all canals. So and canals and power plants we have to see at that power plants and the canals. So that is the pumping, the addition of energy to a fluid, the addition. So extra addition of fluid, extra addition of energy to a fluid. So that is the main concept of the pump. So that is very important of the pumping system. Okay, then the pumping action creates a partial vacuum while atmospheric pressure forces liquid up. Okay, so the pumping, so we see the anywhere, that is the in canals or wherever we are using the pumping system. So we see the pumping action is creates a partial vacuum while atmospheric pressure in the sense of the atmospheric pressure. What is meant by atmospheric pressure? So atmospheric pressure or a gauge pressure and the absolute pressure. So the absolute pressure equal to atmospheric pressure plus gauge pressure. So when the gauge pressure equal to absolute pressure minus atmospheric pressure. So the atmospheric pressure forces liquid. So atmospheric pressure we see in this closed room or something else. So the pressure will acting on that particular body or particular item or particular thing. So that is called the atmospheric levels. So that is called the atmospheric levels. So see here, the atmospheric pressure forces liquid. The pump performance and the specified in terms of Q and H. Q in the sense of the discharge and the H is head. Okay, head of the water or levels. We are seeing that particular head or levels, that is pump performance. So we see the pump performance specified in terms of Q and H. Okay, Q and H. Q is nothing but the discharge. Q is nothing but the discharge, and the H is nothing but the head of the water. So we see the formula for that head of the water or water levels. So that is the H equal to Q by T, and pressure G minus PSG by gamma, okay, plus V square D by 2G minus V square S by 2G, okay, plus ZD minus ZS. This is the formula for the H. H means height of the water levels. Okay. Then then displacement. So we know that the distance and the displacement. So we are discussing in the previous classes, that is the displacement, the discharge of a fluid from a vessel. So the main thing is the displacement. So the main thing is the displacement, the discharge of a fluid on a vessel, fluid from a vessel. Then centrifugal forces. So centrifugal forces, we have to see centrifugal in the sense of the circulation of the forces, we can call it as the centrifugal forces. The circulation or centrifugal forces used to produce kinetic energy. So kinetic energy, so we have a potential energy and kinetic energy as well as the total energy. So the total energy is nothing but the combination or addition of the potential energy plus kinetic energy. So here the centrifugal forces used to produces here the kinetic energy only. Okay, the kinetic energy only. So we know that the formula for that head or liquid, height of the liquid. So height of the liquid or head, that is Q by T equal to PD comma G minus PSG by gamma plus V square D by 2G minus V square S by 2G plus ZD minus ZS. This is the formula for that particular kinetic energy head or liquid head or height of liquid. And the main concept of this types of pumps. So now I am going to explain about the types of pumps. The types of pumps is two types of pumps is there. First thing is positive displacement pumps. This is the positive displacement pumps. Then the second one is centrifugal pumps. Okay, so the pumps is divided into two types. That is first one is positive displacement pumps. Second one is centrifugal pumps. Okay, so the positive displacement pumps, it may be divided into two types. That is, one is rotary pumps. Second one is reciprocating pumps. Okay, first one is rotary pumps. Second one is reciprocating pumps. So here in this reciprocating pumps, it has three types of pumps. First one is a piston pump. Second one is plunger pumps. Third one is diaphragm pumps. So in this reciprocating pump, it has three pumps, that is diaphragm pumps, plunger pumps, piston pumps. Then coming to the rotary pumps, that is first one is gear pumps. Second one is loop pumps, LOB loop pumps. Third one is the screw pumps. Fourth one is cam pumps. Fifth one is vane pumps. Okay, this is the classification of pumps. So different types of pumps is there. First one is positive displacement pumps. In that positive displacement pump, it has two types of pumps, that is reciprocating pump and the rotary pumps. So in this pumps, centrifugal pumps. So here the reciprocating pump, it has three types of pumps is there. That is diaphragm pumps. Second one is the plunger pumps. Third one is the piston pumps. Okay, coming to the rotary pumps. That is first pump is the gear pumps, second loop pumps, third one screw pumps, fourth one cam pumps, fifth one vane pumps. Okay, this is the classification of pumps. And so first of all I want to explain the working two-stroke principles. So based on two-stroke principles, so that is the reciprocating pumps. So in this reciprocating pumps, based on two-stroke principles, so two-stroke principle means two strokes will be there. That's why we can call it as two-stroke principles. So that high pressure, high efficiency. Okay, so it has a two-stroke principles, high pressure, high efficiency. So second one, self-premising. Okay, so first one is high pressure and high efficiency. Second one, self-priming. Second one, self-priming. And third one is a small quantity, vibration, physical dimensions, uneven flow. Okay, used mainly for handling slurries in plant, process and pipeline applications. So the main uses mainly is handling slurries in plant and the process and pipeline applications. So main thing is the pipeline application we are using in this type of pumps, pipeline. So that is pipelines we are installing in that pipelines, that is all our reciprocating pumps. So we have to see, this is the reciprocating pump, the working principle of reciprocating pump. We have to see here, this is the animation of reciprocating pump. See here, this is the two valves and one shuffling box, a rotating mechanism for the reciprocating piston, uses suction to raise liquid into the chamber. So we have to see here, this is the positive displacement pump, piston pump. We can call it as, this is the piston. We are already discussed in the first unit, that is IC engine also. I have explained the piston, what is the importance of the piston and how it is working at that particular piston. So that is the heart of the engine. So this is the piston pumps. So here two valves and one subbing box. Two valves is there. Okay, the two valves is in, this is the one valve and second valve is this. Okay, so a two valves and one subbing box, a rotating mechanism for the reciprocating piston. So reciprocating piston in the sense of, this is the piston. It is rotating from top dead center to the bottom dead center, bottom dead center to the top dead center. Okay, uses suction to rise liquid into the chamber. This is the main thing. So we are discussing about the positive displacement pump, reciprocating pump. In that reciprocating pump, piston pumps, plunger pumps and diaphragm pumps. That is the, this is the one type of piston pump. This is the animation of, we have to see the animation of piston pumps. Okay. And the plunger pumps. So plunger pumps, we see the plunger pump, that is the two balls, check valves on the each side. So two balls, check valves is there. That is the each side two valves on each side. And the low pressure on the upward part, high pressure on the downward part. So here the low pressure on the upward part. So upward part is a low pressure and the downward part the high pressure. Okay, downward part it has this is the upward part. Okay, so low pressure on the upward part. Here the low pressure will be there and the high pressure at downward part. Okay, is it clear? And see the diaphragm pumps. So rod is moved to push and pull the diaphragm. Okay, diaphragm can be used to make artificial hearts. Okay, so we have to see here. This is the animation of diaphragm pumps. See the occasion. Okay, it has also two walls is there. This is the one wall and the second wall. Okay, so this is the finally diagram of that diaphragm pump. Okay, so this is the, it can be used to make artificial hearts. Okay, artificial hearts, we are using this type of pumps. And the rotary pump, coming to the rotary pumps, that is a positive displacement type, high pressure, high efficiency. So positive displacement type and the high pressure, high efficiency. Liquids must be free of solids and handle the viscous fluid, and used mainly in oil burners. So used mainly in this type of rotary pumps. In this type of rotary pumps, we are using the mainly oil burners, soaps and sugars, cosmetics and syrup and molasses dyes link, and then the vegetables and mineral oils we are using in this type of rotary pumps we are using. Okay, and here we have to see here, this is the gas creates voids as they come out of mesh and liquid flow into the cavities. Okay, so as the gas come back into mesh, the volume is reduced and the liquid is forced out of the discharge part. So we see here, this is the rotary pump, this is the gear pumps. We seen in the gas in the last lab also. I have seen the gear pumps, that is belongs to only for gears, that is a helical gear, spur gear like that, and bubble gears I already showed to you. So that is the inside of gearbox. We have to see here, this is inside of the gearbox. We seen in the thermal lab, that is thermal and hydro prime movers. So this is the rotary pumps. We see here, this is the gear pumps. Okay, so gear pumps we clearly mentioned here. This is the gear pumps, and this one is the teeth. Okay. And coming to the fluid is the loop pumps. So loop pumps, that loop pumps is the fluid is carried between the rotor teeth and the pumping chamber, and then the rotor surfaces creates the continuous sealing. So continuous surfaces, here the continuous sealing. And rotors include binding, tri-loop and multi-loop configurations. So we see here, this is the gearbox. This is the gearbox, and teeth is inside in the engine part. So this is the outside diagram of the loop pumps. See here, this belongs to loop pumps only. And screw pumps. So in this screw pumps, we have to see here, screw pumps carry fluid in the space between the screw threads. The fluid is displaced exactly as the screw meshes. So we see here, this is the screw pumps. So this one is the shaft sealing. This is the shaft sealing, and the bearings. This one is the bearings. So we have to design that bearings. Okay, and shaft and screws. So this is the shaft and screws. Then the optional relief valve. So here are two types of valves is there. One is the inlet valve and the optional relief valve will be there. After completion of that one, this is the timing gears. So we will see here, this is the timing gears. In this part belongs to timing gears. Then the pump casting. This is the overall pump casting. So this is the main part of the screw pumps. So once again I repeat it. So this is the shaft and screws. Then the shaft sealing. This is the bearings. This is belongs to bearing and optional relief valves. Here two types of valve will be there. That is, one is the inlet valve and second one is the optional relief valve like exhaust valve. So this is the timing gears. This part is belongs to timing gear and this is the casting. So pump casting. These are all the pump casting. Is it clear? Next, coming to the vane pumps. So the vane pumps is nothing but the vanes are in slots in the rotor. Then the rotor spins centrifugal force. So the centrifugal force is nothing but the one type of the reciprocating motions will be created. It creates the only for kinetic energy. So we know that the kinetic energy. So the total energy is nothing but the kinetic energy, addition of the kinetic energy as well as the potential energy. Okay, so rotor spins, centrifugal forces pushes the vanes out to the touch the casting where they trap and propel fluid. So propel fluid. So we have to see here. This is the direction, that is the clockwise direction. Okay, and the second one is also this is the clockwise direction. We see the clockwise direction here also. This is the finally vane pumps. Vane in the sense of the vane. Vane will be like wings. That is the vane pumps. These are all the vane pumps. Okay. So in this class, what I have discussed is the first thing is classification of pumps. Classification of pumps. And the different types of pumps, that is centrifugal pump, centrifugal pump and reciprocating pump. Pumps. Then the working principle of reciprocating pump. Okay, in this class I have discussed the classification of pumps, the centrifugal pumps as well as the reciprocating pump and the working principle of reciprocating pump. Next class I have discussed the working principle of centrifugal pump and the components of centrifugal pumps. Then thank you.